My name is Ed DeSalis and I'm a Business Development Manager for Shine in Sydney. And I have with me my Principal Consultant for Shine in Sydney, Lincoln Ezra. And we've actually just left our cards on your table, so if there's anything that you need to follow up about after this morning, please don't hesitate to contact Lincoln or I. So I'm going to be traffic cop for today to keep things moving. So the aim is to try and have you all fed and the presentations completed by 9:30. So we've got three speakers for you today, three great speakers who will each be presenting their parts of the Myer project. For those of you who don't know Shine, so Shine is an independent technology consulting group. So that means that we're not tied to any technology in any way. So we're not resellers. So we're not tied to Google or Amazon or Microsoft. But when it comes to data projects, the Google data analytics technology and their machine learning technologies are a class above the other platforms. Right? This is a key differentiator when it comes to data projects at Google. So Shine has been using Google technology since 2013. So we were one of the first to do a large-scale data warehouse deployment for Telstra. And I would say that when it comes to data projects, Shine's consultants would probably use Google, I'd say, 95% of the time. So what I'll do before we go on to the three speakers, I'd actually just like to invite Rudy Burton from Google, who is Head of Partnerships Australia, to say a few words.
Thanks, Ed. Good morning, everyone. Thank you so much for coming along today. My name is Rudy Burton, as Ed mentioned, and I run the partner organisation for Australia and New Zealand for Google Cloud. I'm really excited to have you here to hear what the Shine team are doing. Just to put in perspective, my job is to make sure we've got a strategy of everything that we do is going through our business partners. So my team and I's responsibility is to make sure that we are recruiting, enabling and building practices so that the partners have all of those skills to help you, our customers, with all of the requirements that you've got in the cloud and beyond. Shine is one of our premier partners, and in fact they were one of the first partners to get specialisations down here. In fact, the first partner to get their data specialisation here in Australia. And we've been working really closely with the team. They've got a really fantastic and large team in Melbourne, very familiar to our own business and a lot of the customers down there. And of course, incredibly excited that they're building up a practice in Sydney as well. And so we've got all of the support behind the team, and I'm sure that you're going to get a lot of value out of today. And that was literally it from my perspective. So yeah, welcome. Thank you.
Thanks, Rudy. Okay, now just so you know, I am keeping a stopwatch, so the aim is to get you out of here by 9:30, so we realise we've all got day jobs. So with that, I'd like to ask our first two speakers to come to the lectern, so that Mark Johnson and Aaron Brown from Shine. So Mark founded Shine about 20 years ago after cutting his teeth with Anderson Consulting. His vision was to build a high-quality technology consultancy, and he's built it into what it is today, with about 100 consultants throughout Melbourne and Sydney. As Rudy mentioned, we're a premier Google partner with, and we're only one of two consultancies in Australia with a specialisation in data and analytics. Mark is a data engineer, certified data engineer and a cloud architect. So Mark will give us the framework of the Myer case study and highlight some of the business challenges that the Myer executives were looking to address in that project. Then Aaron will speak. Aaron will give us some further technical insights into the challenges that go with a data project, and in particular building a data lake. So Aaron's background includes scientific computing and data engineering, Dataflow, and using Bigquery and DevOps in the cloud. He's published several peer-reviewed papers on computational chemistry, and he has a master's in science, majoring in maths and physics, and a PhD in philosophy and computational chemistry. And I believe he's also a black belt in Kung Fu, but I'm not sure. So with that, please welcome Mark and Aaron.
Welcome everybody. My job here is to really frame the discussion, so it's a very bad pun. I'm a dad, so I'm required to do dad jokes. But I'm just going to lay out, I guess, the business problem we've got here and some of the background that leads into some of the technical detail of the project, which Aaron will go through because he's much more qualified. First of all, Myer. I don't think I have to explain Myer to anybody. Major retailer, largest retailer by revenue in Australia and number of stores. Founded in 1908 by a couple of Russian immigrants, Sydney and Elcon Myer. Obviously Sydney had a better PR agent because I'd never heard of Elcon before I looked it up on Wikipedia prior to the speech. But yeah, two brothers, very large retailer, huge brand, but we'll talk a bit about the general market a bit after that. Myer One, so it's their loyalty program. It largely grew out of a disgruntled set of shareholders that used to get a discount when they bought shares in Myer. And so they actually decided they had to have a loyalty program to keep rewarding customers. It was part of their first strategy to try and build up really a customer base and a customer relationship and reward that ongoing spend. It's grown to 5 million members, so it's got a really big reach throughout Australia. And they've continually talked about this is really a core to a lot of their digital strategy going forward. So an omni-channel approach, direct offers to customers and things like that. But basically, Myer One program, you collect points for dollars spent at the store. You have tiers, gold, silver, bronze. You get different awards, special events, things like that. And when you get a certain amount of points, then they give you actually gift cards back to redeem in the Myer store. So it's fairly key to their strategy going forward and has been for a while. I should just go back. Just quickly though, Myer One holds a special place in my heart. Their actual initial program was run by Loyalty Pacific, who actually runs Flybys. We've been working with Flybys for 16 years, and I was actually around on the project when Flybys, or the group behind Flybys, actually ran the program for Myer One for the first several years. So I was actually involved in some of the code of Myer One when it first started. It's since moved in-house and has moved other places. But yeah, we've been involved in Myer One way back when. Salesforce, I really hope I don't have to explain who Salesforce is, but I'll say it anyway. Massive software as a service CRM solution. Booked $10 billion in revenue last year, so they've got quite a few customers. In Myer's sense, this is the CRM that they're using for the Myer One program now. So this is where they load up all of their members, the points transactions, and the system that they drive. It's their database of record for their CRM. So really key for them. They're using a hosted version of Salesforce in the Japan region, which doesn't mean anything, but yeah, they're on a hosted version. And so really we're talking about the problem today of transactional information from the point of sale systems in the stores, going through some processes internally, but they need to get it into Salesforce in the hosted solution. Which is mostly transaction information like where you spent, what you spent, things like that. Not detailed information about spending, that's separate. So we talk about the retail market generally. Obviously, David Jones, traditional competitor, often across the street from each other, sharing all the same customers, almost the same branding, I feel like, but anyway. So Myer obviously has competed with David Jones for a long time, but now in a much more competitive environment, especially with digital sales. So new kind of online-only retailers like The Iconic, still very similar branding. I don't know why they can't afford to have colours, I don't know. So then we've got, digital-only retailers like The Iconic. Retail sales generally are fairly flat, but on top of that, they're getting their margin eaten by some of these competitors, and obviously the 400-pound gorilla in the room, Amazon, who's started their local presence in retailing. So they're facing very tough conditions, right? And not only just generally in retail, but specifically digital and online. And so it's really a crucial part of their strategy going forward is anything that can essentially give them competitive advantage, particularly in the digital space, but also help them to lower their costs so they can compete. Right, now I'm going to switch pace slightly out of the business problem into some of the technology. So we're talking a bit about serverless here today. So I guess I want to take you on a little bit of my journey for serverless. And up on the screen, I don't know if anyone recognises what that is, but it's a treasured memory for me, the Dell Poweredge 1850. So this is the first piece of hardware that Shine ever bought way back when, I don't even want to say the year. And I was so proud we actually could afford to buy a rack server and put it into a hosting facility in Melbourne. It was a wonderful machine. We named it. We used to name all our machines. We named this one Einstein, I believe, their very first one. We named them after famous, mathematicians and scientists. And that was followed by Newton and Copernicus and a few others. We would lovingly go in and replace the RAID drives when they failed, and we installed our Jira instances on it still when that was still a thing. Loved our machines and nurtured them for many years, so very special place in our heart. In the early noughties, 2000s, we found this thing called Slice Host, and suddenly we could log into a web console, we could click a button, we could get an instance brought up, and if we wanted to, we could throw it away. Of course, we never threw it away. No one ever throws away machines. So we would just collect a whole lot of machines. But now we weren't quite as personal, like we didn't have that same reaction to them. And so now I named them things like your initials, dash the application, dash the environment. So MJ, Jira, prod, right? So it wasn't quite as special, but we still kind of had to patch them. We had to do lots of stuff to them, but it was just easier to start them up, which just meant we were just collecting lots more of them. So instead of having a couple of machines, now I had 20 of them. But Slice Host was great. And it was really the beginning of that public cloud, which we all know about and are here about today. In 2012, there's a classic presentation by Bob, I forget his name, can't think of his name. It was actually about scaling SQL Server, if you can believe it, but they talk about the concept of scale out, not scale up. And this is the concept of we shouldn't think of machines as pets that we nurture and love, and if they get sick, we bring them back to life and look after them. We should think of them as cattle, right? So if something goes wrong with one of the cattle, you just get rid of it and get another one, right? And this is the real fundamental behind a lot of the public cloud infrastructure today. You shouldn't be worrying and getting, concerned when you lose one. Just start another one up and keep going. Which then leads to the next iteration beyond that, which is serverless. I was going to try and find a slide on that, but I was worried about the transition from cattle and what would come after that. So I'm going to leave this slide up there. But serverless then is the concept that you don't even care about the instances anymore, right? So you're provided with a platform with a technology where you're just delivering the code that executes and does something. Runs a web server, processes some data. But you don't even worry about anything. You're not getting access to those instances at all, right? And so you're not patching, you're not worrying about security, you're not doing anything. So it's that next iteration beyond. And so really, we see serverless as a key differentiator, particularly in Google, moving forward, because it lets you focus on what you need to do and not worrying about the infrastructure. So Myer isn't in the infrastructure business, they shouldn't be in that, but what they are, and they're worried about trying to compete, and hence serverless technology is going to help them do that. So Google Cloud Platform, so started in 2011, and in fact their very first product in Google Cloud was App Engine. It was a serverless solution where you could give code and run a web server, and they would worry about all the scaling and the patching and everything like that. So Google started, their first step was into serverless. That's where they thought the future was, and I think that's still true. They've since gone back and filled out the product category with lots of capability, right? And you can still get an instance and you can still do all those things. But they've led with a serverless approach from the start. So other really great serverless products, Bigquery, so a structured data querying on a massive scale, completely serverless. You just use it and you pay for what you consume. Dataflow, which is a technology that Aaron will talk about, hosted version of Apache Beam for processing data, files or streams. You just give it your code, you don't worry about the infrastructure at all, it scales out as required. We don't have any cattle even anymore. To finish up, I'm here to frame the problem, so we'll go back and just quickly recap. We're talking about Myer, a major retailer, facing a lot of competition. They're using Myer One as their loyalty program. It's a really key to their omni-channel approach. They need to make sure they're doing that well and efficiently. Salesforce is their CRM, and we need to be working with that in the hosted sense. And Google Cloud is the glue that we're going to use to bring those things together. And hopefully by the end of it, we won't have hurt any cows. So with that, I'll hand over to Aaron. He'll talk you through some of the details of the actual project and what we did.
Cool. I'd like to thank Mark for that introduction, both on serverless and Myer as a business. So now I'll give you a bit more details about the project, what we actually did, and some of the problems that we had to solve. So, as Mark mentioned, Myer moves a lot of data into and out of its CRM Salesforce. And it does this based on a custom managed file transfer solution that's part IBM Sterling, part some Blue Logic in a MuleSoft Enterprise Service Bus that they use. And for this, what they found is that their MuleSoft licensing costs are relatively expensive compared to the business value that they're able to get by moving the data into and out of Salesforce. And as such, they would like to reduce these costs when the licensing is up for renewal. And they're also finding that Myer has many, many third parties. You know, if you think of all their suppliers, people they're partnered with to provide the Myer One credit cards, and they require receiving data from all of these third parties. Now, not all third parties are created equal, and some of them both send bad data, which causes errors and people have to go in and manually fix things. But also some clients or some vendors are not very good at actually sending the data in a timely fashion. So they'll send like 3 weeks worth of data on one day. And so that they're one of the things they're finding is with their current solution, they're spending a lot of time propping it back up where it's fallen over because of the sheer volume of data that it's trying to process. And then just to compound this issue, they also have their own quarterly mailing process in which they basically decide we're not going to process any data of our own for 15 days or up to 15 days, and then hit go and let all of the data go through their MuleSoft implementation at the same time, which again causes them some headaches in terms of scaling. And so hopefully these are some of the issues that we're going to try and address. So let's think a bit more about the actual project and the technical problems that we need to solve. So in total they've got 39 interfaces, both into and out of MuleSoft, from various different third parties. Each file is in a different format, even though there might be 2 files with the same data. You can guarantee they're in different file formats. There's a dependency between the jobs, so for example you can't load transactions in for items that you haven't items that you don't have in your CRM yet. We had less than 12 weeks to go from a blank GCP project to being in production, and that was mainly driven by the fact that the primary business value for this project was to avoid the license renewal. And so if we delivered after the license needed to be renewed, then while the project would still be viable and worth doing, the business value for it would be significantly less. And one of the other things they were after was they would like it to be as easy to maintain as possible, so they wanted it to be a fully serverless solution, so that we didn't have any of the cattle or the prized possessions that Mark spoke of earlier. And one of the other key things is it needs to be easy to maintain. So we need to build something in a way that their current ops team, even though they might not be particularly experienced in these technologies, that they can understand and really get in and add new files when they come up. But that's okay, right? There is hope. I'll leave it up to you guys to decide which one of us is Obi-Wan and which one gets to be Luke. But we've done this before. As Mark alluded to, we've done this for other clients, and I personally have worked out at Telstra, where we've built out a huge data lake for Telstra Media. And we'd also done a proof of concept for one of the more complicated interfaces in this project, which is great, because that means there's only 38 left to go. Which still quite a daunting number, but 38 is better than 39. So then we started studying the interfaces. So I had the unenviable job of sitting through 39 interface definitions that described how the files came in through MuleSoft and ended up in Salesforce and came back out the other way. And once you actually start looking at them, you notice a lot of things. One thing, there's a lot of repetition. There's a lot of similar Salesforce actions and similar data moving about. And so when you actually take these 39 interfaces in and out of Salesforce, they actually really boil down to 5 distinct types of input job, 5 distinct types of output job, and one job that deletes records every now and then, basically when they find that Salesforce is getting a bit full, they run a job that deletes some historical data. And so with this realization, we were able to kind of turn it, rather than a development problem of we've got to develop 39 unique things, we turned it into a problem where once we build an actual framework for these data ingestion and export jobs, it then becomes a configuration problem. So let's take a look at one of those jobs. So here, and I don't expect you to be able to read all of the little tiny boxes, there's only two that are actually important and we care about, and that's these two. So this is what a Dataflow job looks like under the hood. The graph shows you how data moves through the solution, so in terms of how records are grouped together. But the key point is, the only bit that's specific for each of these 39 flows is those two red boxes. The rest of it is a framework that we've built up and provided, and even then, a lot of the functions, for example, group by or reading files, they're all provided for us by Apache Beam. And so with that, we're able to maximize the number of components that are reusable. And also in this, we haven't yet had to worry about scaling or performance or anything like that. So what did we actually build? And what we built was this. So it's fully serverless, and it's based on using Google Cloud Storage to receive the files, and then it's event driven from there, so that triggers Cloud Functions that then launch the Dataflow jobs. And so it doesn't matter if your vendor decides, you know what, they're going to give you a month's worth of files in one day. We just launch that number of Dataflow jobs to get the data processed and loaded into Salesforce. And then by doing this, it frees the operations team up. So rather than what they're doing now, which is currently making sure that the systems keep running and they keep processing the data, they're now able to focus on, okay, what insights and what value can I get from that data now that I've got it into Salesforce? And as I mentioned, it's also scalable, so we've got the scaling out covered, and thankfully Google's also taken care of things like reliability and performance, which has really freed us up to focus on just the key business problems. And we also use Stackdriver for alerting, which again saves us from having to think too much about monitoring and alerting and reporting. So as I alluded to on the last slide, we haven't spent much time thinking or planning infrastructure, buying bespoke servers, choosing a naming scheme for them. We've just focused on getting the job done, getting the data transformed into and out of Salesforce as it's required. And all of that other heavy lifting has been done for us by GCP, in Cloud Functions, in Dataflow, which is nice. Which is good, because halfway through the project, project manager for a different team taps me on the shoulder and goes, I hear you're doing this MuleSoft replacement project. I'm like, yeah, okay, yeah, I'm doing that, building it out, so we're replacing. And he's like, I'm building out a data lake in Bigquery. Could you just take all the data that you're currently sending back out and just send it off to us as well? Which, as I alluded to earlier, we've got this 12-week time frame, and someone's going, cool, all right, let's increase the scope. But because of the framework that we'd built and because of the flexibility of Dataflow, we were able to accommodate that and just add an extra output on our processing pipelines and say, okay, cool, that's fine. We're going to build the traditional output flat file, so the CSV or the tilde limits file, but we're also going to send a record into BigQuery as well, into their data lake. So we're able to, once we had this data framework built up, we're able to just extend it very easily and accommodate even last minute requests such as, hey, help us with the data lake as well. So I guess what were the key things for this project? And what I feel is with these data engineering type projects, getting a good framework and a good basis is vital, and I feel that's where our experience can really help. Because the idea is once we've set up this job with the framework and the processing in place, then for the ops team to onboard a new file, it would just be a case of going, okay, this is what the file looks like, here are the fields and how they map. And they don't have to care about anything, so it really tries to put the power in their hands to derive value from the data that they gain. It's also worth taking a while to look at the data that you're trying to process and how you're processing it, to identify any of the common components, and that will really help inform that framework. And we were also able to, as I said, accommodate last minute changes in scope, which included building out that data lake. So that was the Myer project. So I think
our next speaker, Russell Nash from Google. Russell is customer engineer, big data analytics for Google. He's had 20 years experience across analytics, database and web content management systems. And if you look at his LinkedIn profile, he has a passion for presenting, demonstrating and prototyping technical solutions. He's worked across both Amazon and Google Cloud Technologies, and he's a seasoned presenter when it comes to all things technical. So would you please welcome Russell to the
Thank you very much, Ed. Good morning, everyone. Ed and I were chatting before, and we realised that we had actually been to school together a couple of years apart. And the scary thing about conversations like that is it forces you to work out how long it's been since you were at school. And the numbers seem impossibly large, as if there'd been some kind of mistake. So my role at Google is to spend time with customers, talking to them about their businesses and how Google Cloud can potentially help them with what they want to do. And so I want to talk to you a little bit about that today, because one of the questions that I get quite a lot is, why Google in the cloud space? What are the differentiators for Google against the other cloud providers? And for me, there's a couple of really key ones. The first one is the experience that Google has in running infrastructure at scale because of the other properties that it runs. We'll talk a bit about that. And the second thing is that Google's leading in a couple of really key areas of innovation at the moment that a lot of businesses are really interested in, and we'll talk about that as well. So if you think about some of the other consumer-facing properties that Google has, each of these has got 1 billion users each, from search all the way down through to Gmail and GCP. And so you think about the infrastructure that you need to support 1 billion users, and obviously you learn a lot when you do that. And so over the years we've had to build that infrastructure, we've had to build the networking to support that, and obviously the expertise in running this type of infrastructure. And on top of that, we then built a lot of software, a lot of frameworks, and a lot of libraries that we've then open sourced. And so you can see some of those in, say, for example, Kubernetes. So Kubernetes, if you're not familiar, is kind of the orchestration layer of choice now for many organizations for their container strategy. So if you think about what Mark was talking about with on-prem servers, and then that move to virtualization, and then the move to the cloud, the next step from there is containerization, where you get even more granular control over your compute. So Kubernetes is at the forefront of that, and that was an open source project that came out of the way that Google managed their infrastructure to support these properties. One of the other key areas where we had to innovate was around analytics. So you can imagine 1 billion users generate a lot of data exhaust, as I heard someone say the other day, and we want to analyse that data, obviously. So we need to analyse data that might be streaming, that might be at rest. We want to use SQL, we want to use machine learning, and so we've built a lot of technologies along the way to support that. Now when we do that, a lot of those technologies will open source, but also we then make them available to customers on Google Cloud as well. And when we do that, there's a couple of key things that we always bake into those services that allude to what Mark and Aaron were talking about around the serverless strategy. So we don't want customers to think in terms of servers or clusters or nodes or anything like that. We want you to just think in terms of services. So one of those services, to give you an example, is Bigquery. So Mark talked about Bigquery. So Bigquery is a service that you can use on Google Cloud that is an engine for analytics driven through SQL. But you don't provision anything when you use it. You don't say, I want to have a cluster of this size, or there's going to be this many users, or anything like that. You simply just load data into the service, and then you query the data through the service. And if you look at the history of it, it came out of this process that I'm talking about, where we built this for our own needs internally, because we had a lot of frustrated engineers who were trying to get answers from the data, and they were finding that it was taking too long, it was too hard to get access to, they had to write Java, it was using MapReduce, which was slow, and so they went and they wrote something that was much more interactive and that had a SQL layer to allow people to get access to it. So that is the service that we built internally. We still use that today, and that is now the Bigquery service that we make available to our customers as well. The other interesting thing that a lot of customers want to talk about is machine learning. And machine learning is obviously everywhere at the moment. Everybody's talking about it. Everybody says you should be doing it. Everyone wants to sell you something with machine learning embedded in it. But there's a couple of frustrations. And one of the frustrations customers have is they say a lot of the use cases they read about are the really high profile sexy use cases. So it's self-driving cars and robotics and curing cancer and all of that kind of thing, which is all very all noble pursuits and very important. But sometimes they feel like it's not really, how do they use it in their day-to-day business? Now, the good news there is that I like to refer to it as the rising tide. So all of this research that goes on in these high-level projects, all of the things that get learned, all the expertise, that all filters down into services that you can then use in your business. And there's a bunch of different building blocks that you can use on Google Cloud where you don't necessarily need to have machine learning expertise, but you can embed some of this technology into your own applications. So that rising tide means that you as a business can start to use some of this technology. The other concern customers have on machine learning is those of them who've been around for as long as some of us have, is they've kind of seen this hype cycle of artificial intelligence and machine learning. So in the 70s, 80s, 90s, there's been this rise of excitement about what AI is going to bring, and then it's followed by this lack of enthusiasm, things don't work out, people lose their jobs, and it's kind of, all of those projects are shelved. And it happens so often that it actually has a name, so it's actually called the AI winter, and because it follows this period of excitement. So a lot of customers say, is it for real this time? Are we actually going to get some benefit this time? Should we invest in this area? And the answer is yes. So there's a couple of reasons why now AI is really here to stay and is starting to deliver some value. And the first of these is the innovation in the actual algorithms themselves, the actual software that runs a lot of the machine learning models is becoming incredibly sophisticated. And one of the reasons for this is that these are all open source now. So we live in an open source world where people are creating communities, they're collaborating, they're really moving the ball forward in each of these different areas. Whereas previously a lot of this software would be proprietary, companies would keep it close to their chest, they wouldn't want to share it. So this collaboration effect with open source is really starting to push the boat out for the algorithms themselves. Now I've called out TensorFlow there, not to say that TensorFlow is any better than any of the others, but this is again a technology that we developed at Google to deal with our own machine learning problems, which we then open sourced, and it's one of the more popular open source libraries. And my point here is not that you should be necessarily using TensorFlow or maybe that you would ever use it, but if you are partnering with Google, you're partnering with someone who understands this technology at such a deep level that they actually built one of the leading algorithms in this space. Now, hand in hand with the algorithm side is advancements in hardware as well. So one of the big leaps forward for machine learning over the last few years has been the use of GPUs. So GPUs, graphical processing units, came out of the video gaming industry in order to improve the frame rates for players when they're playing games. And some smart brains at Stanford realized that the calculations that were being done for gaming was exactly the same as the types of calculations they were doing for machine learning. So lots of very simple calculations, but done at a very large scale. So that's what GPUs did. Really, was they were much more focused on doing lots of small things quickly than lots of large things like CPUs were. Now, Google and others have moved the ball forward on this as well. So this is actually a TPU. So this is a tensor processing unit. So a similar concept where we're doing lots of very, very small calculations, but doing them at massive scale. And so, and these are now available to customers on Google Cloud as well. So again, not saying that you should be jumping on and using TPUs, but again, you're partnering with someone who understands that technology at such a deep level that they're actually building their own hardware. So I know it's a bit early in the morning to be looking at circuitry. I apologise for that. I wanted to also talk about this. So one of the things that we see across customers, but also within large customers too, is a real range of machine learning problems. And these range from the generic through to the more custom. So a generic machine learning problem is one that is beneficial to you, but is probably been solved by other people as well. So you want to analyse this piece of text to pull out the sentiment of it, for example. That's a fairly generic problem that you could probably just get a building block to do that for you. Through to more custom problems that are probably unique to your business. And so within Google Cloud, there's going to be different building blocks to serve each of those different areas, whether you need to go generic all the way through to custom. I wanted to leave you with a customer example. So there's a customer out of the UK called Ocado, and they're a grocery retailer, but they do deliveries of groceries. That's basically their primary business, and it's quite a sophisticated operation now. And they use machine learning at a number of different levels, including Bigquery as well, and some of the streaming technologies too. And there's a number of use cases that we could talk about. So they do things like they do product recognition for their robots. So when their robot pickers are picking out the right produce for a particular customer, they can pick the right one. They use it for product recommendations for their customers, fraud detection, demand forecasting, all of that kind of stuff. But the one use case I wanted to talk about is the most boring one that they have. And I want to talk about it because it's a boring use case. Because my point is that while we focus a lot on this kind of sexy use cases for machine learning, it's often the really, really basic ones that deliver the most value. So one of the problems that Ocado have is they receive a huge amount of email every day. And these range from very, very time-sensitive, urgent emails, such as, I'm expecting a delivery at 4 o'clock, but I'm not going to be home. Can you deliver it at 5 o'clock? Through to, great job guys, love your service, which obviously can be responded to later. And what they found was that they weren't getting to the urgent stuff quickly enough because they had to sort through all the other stuff. So they simply trained a machine learning algorithm to look at the text in that email and then prioritize it based on what they saw in there. Such a simple use case, such a boring use case. Email prioritization, does it get any more boring than that? But the impact on their business was huge. So they found that they could get to those important emails 4 times faster than they were previously. So it had a big impact on customer service and obviously everything that goes along with that. So I wanted to leave you with that. I think we're going to open it up to Q&A. So I think any questions you've got for me or for Mark or Aaron, feel free to fire away.